Yeah, you need 3. You need 3. You do. You need 3. I don't think you need numbers. 5, do you? No, she didn't give them that. She gave them number 7. And number 9. Oy. Hi, Jason.
Hi,
How are you doing?
I'm doing good.
Good to hear. What did you come to work on today?
9.1.
Oh, 9-1. Okay. How far did you get with that?
I haven't started it yet.
You haven't started. Okay. I put up a video for that last week, and I just put up a video for 9-4 this morning because we're skipping 9-2 and 9-3.
Okay.
So 9-1, 9-4, and 9-5
Mm-hmm.
are where we need to be. Let me douse this and go back. Let me find the 9-1 because I have it downloaded already. Yeah, here it is. And if I go and grab that, there's a couple of things about 9-1 that I need to, let me grab that one. And also, while I'm here, let me grab the, I need the studio. I don't need that. I need the studio to take you. So, let me see. 9-1, where's that? Yeah, I think this is, here it is. This out and we'll wait for that to appear. Okay. So before we get to that, let me make sure we're all together. We are. And let me make sure we have the PowerPoint. Yeah, we do. Okay, now let me make sure that I'm actually sharing, which I'm not doing yet. And I have to make sure that we have the captions on also. So I'm gonna do my recording here, show the captions because that's a mistake I made last time. All right, so 9-1 is about testing the differences between 2 means, 2 variances, and the chapter is about these 3 things: 2 means, 2 variances, and 2 populations. 9-1 is about means. Okay. There is a question before this. So let me shift to the homework, because there's a question before this question about assumptions, about what the difference is between testing for 1 mean as opposed to testing for a mean difference, which is, which is a big deal. And she doesn't really tell you in the notes what it is, but essentially, when you're testing for one mean, you're testing the mean versus the value of that parameter, not the mean versus another mean itself. So that's the major difference there. And actually, if I go to, let me see if I can figure out where I'm at here. Is this the one? Yeah, this is the one. Let me run it over here. Run it all the way from the beginning, because I want you to see this part. This is my hold on, way too much stuff open. You know what I'm gonna have to do? I think I'm gonna have to. Okay, let's see if I can share from here. I'm having an issue with this. So let me optimize for my there, and here we go. So this is the beginning. For some time now, we did hypothesis testing for one mean in section 8.2 when we knew sigma and we generally had a large sample size. We used the z-test. And then if the sample size generally were smaller and we didn't have sigma, but we had asked the sample standard deviation, we used the t-test. We did that in 8.3. Then we went on to the test for proportions, single proportion in 8.4. And we just finished testing variances and standard deviations in 8.5. In this section of chapter 9, we're going to cover hypothesis testing for two means. So you're comparing two populations with each other, and you're comparing those means with each other. So let's begin by taking a look at the difference between testing a single mean and testing the difference between two means is that when testing one mean, the parameter is compared to a specific value. When testing the difference between two means, the values of both parameters are compared to each other. So that's something like that. That's something like what you can write for question 1, because question 1 is asking you on the homework, explain the difference between testing for a single mean versus testing the difference between two means. And she didn't give you anything in the slides about this, because I checked it, and that's specifically why I wrote it. So essentially what's happening here is when we were testing one mean, it was something like HO we have mu is equal to, say, 72, right? We're comparing the mean to some number that we know. We're comparing the parameter to some value that we have. In 9.1 and the following sections, we get something like this. We're comparing two means together. So we get something like HO, and we get mu1 is equal to mu2. So we're comparing two means to each other when we do that. Okay, that's the difference. So when testing one mean, we compare the parameter to some value that we have. When you're testing the difference between two means, the values of the parameters, the means are compared to each other. That's question 1 on the homework. Okay.
Let me write that down.
Are you able to see it on your screen okay?
Yes.
Okay.
There.
Okay. All right. The question 2 is asking you about the underlying assumptions, which she does give you in the slides for 9.1. So let me show you that. The second question about 9.1 is the assumptions for determining the differences between two means. And these are your assumptions here on slide number 3. Each bullet point is an assumption.
So it says both samples are random samples?
Random samples, that's the first one. Both samples are random samples.
Okay.
The second assumption is that the samples must be independent of each other. So those are very common. And then the standard deviation of the variable must be known. So we have to know sigma. But if the sample size is less than 30, the population must be normally distributed, normally or approximately normally distributed. We're not doing a t-test for 2 samples. We're only doing the z-test. So for those of you who are watching this later and wondering about it, that's one of the sections that we skip, is the t-test. We're doing just the z's for this chapter. So
What happened? Sorry,
I
I had to
said,
get something.
no, that's fine. What I said is that we normally would have a z-test for 2 samples and a t-test for 2 samples. We're not doing the t-test. We're skipping that section. We don't have time to cover it. So we're only covering the z's for 2 samples. You'll see when we actually get to the problems, which is going to be the next question is going to cover that. Okay.
Yep.
Are you good with this one?
Yeah.
Okay.
It's just the first 2 on the sides.
It's all 3.
Okay.
All 3. You can abbreviate this. You know, the standard deviations are sigma 1 and sigma 2. So you can abbreviate if you don't want to write the standard deviation. So if you want to shorten the third one, you can write this. You can say, let me see, where's my annotation? Okay. You can write for assumption number 3, if you want to make it shorter, you can say sigma 1. And remember, I don't have a sigma, so I'm going to call it O1. Sigma 1 and sigma 2 are known. And if N1 or N2 is less than or equal to 30, then the population must be normally or approximately normally distributed. That's the short version of what's on the screen. It's the same thing. It just saves you a few words from having to write the standard deviation and the sample size over and over again. Okay.
Okay.
All right, now we're going to get to the real hypothesis testing. The nice part of this,
Hold on, so writing down.
Sorry, no problem.
It's fine.
Let me go
It's
back.
fine. Okay.
Yeah.
Hold on, not yet.
Not yet? Okay.
Okay, there.
Yeah? Okay. So now we're going to go to the actual homework. What I should mention for this, if you haven't had a chance to look at the material, is we're doing p-values for the whole chapter, as I mentioned before. So let me make sure I'm getting the right homework first. There it is. There's our homework for that. Okay. So we've done, let's see, let's go here. Here's the homework assignment for 9-1. Okay. So we've covered 1 and 2. And it says in exercises 3 through 8, perform the following steps. Now, again, we're doing the p-value. So you have to, I asked her to fix this. So this might be fixed by the time you're seeing this. But when she wrote these steps, she wrote the steps for the traditional approach. So step 2 should be find the test statistic. Actually calculate the test value. Calculate or compute. She used compute, so let me use what she used. Compute the test value. Then it's going to be step 3. So this is step 2. Okay. Compute the test value is going to be step 2. And then step 3 is going to be as soon as I can get this message off my screen. Okay. Step 3 is going to be to find the p-value, and then we're going to make the decision just like before. So step 3 here is going to be the report the p-value. And I'll show you that when we do question 3 right now, but just so you know, that's what we're following here. So change this. I'm going to cross this out because these two are wrong. Make the decision. We still do that and we still summarize the results. But 2 and 3 are as you see on screen. Now, number 3 is a little bit of a pain. It's the only problem in here that involves raw data. So it does take a minute to put all the raw data in your calculator. I'm going to bring up the screen in a minute, but I just want to make sure you're aware of this first. So what I'm going to do now is bring up the data. What we're going to do here, and I don't have this in my calculator at the moment because I was working with some other data, but I do have it in the video, so I can go back to that and show you. But let me, first of all, get us the problem. Here is the data. We have 2 sets of data, one for the US and one for Europe. It says a researcher wishes to see if the average length of the major rivers in the United States, so this is our group 1 over here, okay? Group 1 is over here in the US, and group 2 is Europe. So you're gonna wanna put all the United States in a list, probably list 1, and all of Europe into group 2, L2, okay? The data in miles of a random sample of rivers are shown. At alpha equals 0.01, is there enough evidence to reject the claim? Notice they gave us sigma 1 and sigma 2, but you still need to put the data in your calculator in order to be able to do this. So that's group 1. I'll leave it on the screen, and then we'll go back to the video and watch. We'll go through the solution there for this one.
Oh, I have to put that in a calculator?
Yeah, you have to put group 1 in the calculator and group 2 in the calculator. So let's see. So you're gonna go ahead and let me switch my screen share so I can actually maybe you still need it. Let me put it up here. And while you're doing that, I'm gonna go to my mouse, scroll forward to my let me clear the drawings and put up my new share for the video here, right here. So I got my data, I think. Let me see if I got my data in at this point. I think I did. Yeah, I did. So let me go and do, okay. So once you get your data in the calculator, turn off the captions on top of the video so that for those of you who are using these, you don't get too messed up in there. And then I will, once you get it in, I'll show you how we set this up. on it. Okay. These directions up. Let me pause the video. Everything that you see that says Europe, I put in L2.
Oh, okay.
And then I run my stats. So this is, I put the United States in group 1, and I put Europe in group 2. And now, I think I was letting the student do some of this. And then we start looking at setting up our problem. So then, and let me run this on a playback speed that's a little bit faster for you. So our parameter here is the population mean difference. And so that's mu. Your claim, I'm going back to here. The claim is that, is there enough evidence to reject the claim? They want to see if the average length is the same. So your claim is actually HO in this case. So once you have your data in your calculator, then you can start to write out your hypothesis test. You'll see where this is going in a little bit. The calculator isn't going to be any help to us with step 1. It's going to be help to us after that.
So it's population mean difference sigma?
It's not sigma, it's mu. Population mean is mu. So it's mu
Okay.
here.
Oh, it's the U?
Yeah, it's the U. I think it's because this bar in the way. Let me see if the bar will out of the way. Can you see now? More?
Yes.
Okay. And I just basically made a note up here that mu1 is US rivers and mu2 is the European ones. That's kind of a handy thing to know. Your method here is the p-value approach. Your test is the 2-sample z-test using data. Now here, this is a different thing, and you'll see this when we go to the calculator. We have 2 options when you put in your, when we actually get to the hypothesis test. You have 2 options. That's going to be data and statistics. The rest of the problems on here have to deal with statistics. This one is data. You want to be sure and indicate that then when it says test, this is the name of the test in your calculator, 2-sample z-test, and you're using data for it. Okay. So our step one was to write our hypotheses. And then step one of your hypothesis test looks as you might expect it. Remember, your claim is HO.
And I guess for number two, it's tail statistic.
Right. Number two is the test statistics. So let me show you where that comes in. I go to the calculator and I show you here that, did I have it running? Yeah, I do. So there's so you go to stats, you're gonna right arrow to tests, and you're gonna go down till you see the 2 sample z-test. And as you can see here, you have an option to put in data or statistics. Data is going to be the raw data all the time. So if you have lists of numbers that you put in a list, you're going to use data. Statistics, you're going to see we do when we get something with sample statistics in it already. Remember, she gave you sigma 1 equal to 450 and sigma 2 equal to 474. So make sure you go to the 2 sample z-test on your screen and enter the things that you see here. And then I'll let it run through and show you what we got. Because there's a couple of things that we have to pay attention to. So once we get that in there, I have this. Once I hit enter, I get this screen. And the things that I want to pay attention to on this screen, my test statistic is right here. Z is my test statistic. Make sure that you set your alternative to not equal to. And your Z is negative 0.8560. And your P which is your p-value, is equal to 0.3920, because there's an 8 after the 9. 0.39, 20. Okay. Okay, so now once we get those values off the calculator, then we go back to our whiteboard, and you'll see me fill in the stuff on the whiteboard here. Okay, so I filled in those values from the whiteboard, from the calculator that you just saw. Okay, now we're going to make the decision here. So here's my note. We will solve all the assignments in the chapter, not just the section, using the p-value, okay? So all you have to do is report it. Now, this is what your hypothesis test, I think I forwarded it a little too far. Let me go back one bit here. There we go. There's my, oops. So there's my hypothesis test. Here I'm reminding you what the claim was and what the decision was. And I'm also reminding you to underline appropriately. So here's your hypothesis test for number 3, okay? With the 5 steps listed. So your hypothesis test for number 3 should look like this.
I already wrote it down. I was looking at the video also.
Oh, okay, cool. All right, well then the other problem that's on the video is number 10. So we'll come back to that, or you can watch it later. But the rest of the problems that are in the section are, the major difference is that they're statistics. So the process is the same, but you're doing statistics rather than data. So here, let me stop sharing this screen and share the homework again. So problem 4 is talking about the US Census Bureau, okay? The US Census Bureau reports that the average commuting time for citizens of both Baltimore, Maryland, and Miami, Florida is approximately 29 minutes, okay? To see if their commuting times appear to be any different in the winter, random samples of 40 drivers were surveyed in each city, and the average commuting time for the month of January was calculated for both. So you see that we have the average commute time for both of the cities. We have 28.5, we have 35.2. The results are shown at alpha equals at the 0.05 level of significance. Can it be concluded that the commute times are different in the winter? So remember, just for some context, these are your n's, your sample sizes. These are your X bar, and you'll see why you need that in a minute. And these are your sigma, okay? Population standard deviations are your sigma. You assign the groups yourself. You can assign the groups yourself. So if you want to call Miami Group 1 and Baltimore Group 2, you can do that, but you have to specify. So when you when you put this in the calculator, before you start doing your hypothesis test, this is mostly for the person who's reading it, okay? So what we're going to do now is we're going to do pretty much what we did last time. We're going to get a new whiteboard. And we're going to say that this is question 4, okay? So we're going to have our parameter is population mean difference, or just population mean. I like to call it the population mean difference sometimes, just to distinguish it so you know you're doing 2 of them. But if you write population mean, that's fine too, either way. The next thing I did was to put in, this is going to be the claim here. If you put the method, I don't remember if I put the method next, but as long as you get the type of test, the method, all that. Claim is, we're doing a type of test. Let me do this like this for the sake of this. We're doing a two sample z-test, but this time it has statistics. Because one of the things she's going to ask you on the quiz is whether you're using data or statistics, two sample test. You're doing, this is the method, is the p-value approach. Your claim is that mu1, they want to see if they're different in the winter. So this time your claim is mu1 is not equal to mu2, right? Because you want to see if they're different. So here, mu1 is not equal to mu2. And remember, I like to put which hypothesis this is. This would be H1. H1 mu1 is not equal to mu2 because can it be concluded that they're different in the winter? Okay. So now we're going to go to the whiteboard and share it here. All right, so now we have our data and we can say that group 1, we're gonna say mu1 is going to be, or group 1, let group 1 be Miami and group 2 be, was it Boston? Is that what the?
This is H1?
H1 is our claim. This is my setup still, okay? I have to set up the I have to state which groups are which, okay? H1 is my claim. H1 is mu1 is not equal to mu2. And group 1 is Miami, and group 2 is Baltimore, right? So now I'm ready to do my stages. So I have H1. This is step 1. It's going to be my no is mu1 is equal to mu2. It's going to look almost the same as the one we just did, except that your claim is going to be H1 this time. Mu1 is not equal to mu2. And mu1 is not equal to mu2. mu2. There we go. Now this is my claim, and it's a two-tailed test. We know that. So we're going to write claim, and we're going to write two-tailed test over here. So then okay, so that's my step 1. Now, I believe that I did this earlier, but I don't have the, let me see. Let me go ahead and bring up the calculator and the data. So let me show you that, because we haven't done this yet. So here, I'm going to go back to my problem briefly, because I need to record my stop. So Miami has a sample size and is 40. This is N1. My sample mean is 28.5. And my sigma is 7.2. And my Baltimore is 40, 35.2, and 9.1. So the way this looks is we're going to go to, before we can finish our hypothesis test, we have to go to our calculator. But this time we're going to go to stat. We're going to go to tests. We're going to go to 2 sample Z, which that's where we go. But this time we're going to choose, whoops, except I didn't choose the right one. We're going to test 2 sample Z. Make sure that you don't accidentally click the T like I did. 2 sample Z test, number 3, okay? 2 sample Z stats. Now, you're going to fill in your sigma 1 and your sigma 2. Sigma 1 for Miami is 7.2. So I'm going to put 7.2 in as sigma 1. Sigma 2 is the standard deviation for Baltimore, which is 9.1. So 9.1. Your X bar is your sample mean. So X bar for Miami is 28.5. And your N1 is 40. And 2, I'm sorry, X bar 2 is 35.2.
I don't have X bar 2.
Make sure you're on 2 sample Z on your calculator.
Oops.
Make sure you're on the 2 sample Z screen. If you don't have the right data elements, you're probably on the wrong screen. Okay, it happens, especially when you start. Be careful there. Do not try to bowl your way through if you don't have the right elements. You're probably on the wrong screen. Take a minute, make sure you're on the correct screen, okay? And N2 is 40 again here. Now, when you get done entering those, the next line asks for your alternative hypothesis. Notice it has a 2-tail, a left tail, and a right tail. This one is a 2-tail for us. So once you get this all in your calculator, the way you see it on my screen here, (7.2, 9.1, 28.5, 40, 35.2, and 40, mu1 not equal to mu2, you can calculate it. When you calculate it, you'll end up with 5 values on your screen. You only need the first 2, okay?
Okay.
Okay. Z is negative 3.6518 if you're going to 4 places. We'll see what she put on the answer key in a minute. Be careful here. I always have students that have questions about, whoops, my
Wait,
apologies.
what?
I hit,
What's
yeah,
the Z
no.
again?
I have negative 3.6518.
Yeah, I got that too.
Okay. Let me put it back up because I accidentally hit a key and it and it went off somewhere. So there it is. Students always have questions. I'm going to show you something. Students always have questions, and we've seen this before, but not recently. So one thing to be aware of, this p-value, this is a probability, right? It shouldn't be more than 2 or more than 1 actually. But you've got this E negative 4 over here. So be careful with that. That means that the actual value, you have to move the decimal point 4 places to the left. Okay, so there's actually 3 decimal place. Well, there's 3 zeros, 4 decimal places, but 3 zeros in front of this 2. So your p-value here is actually, let me put it up on the screen here. This is 2 point, let's say 605, okay? And we're doing e to the negative 4. So this means that you're actually, what you're doing is you're taking this decimal point and you're moving it 4 places to the left. So here, you're going to end up with some zeros in front of it, right? So you're going to end up with your p-value. You're going to report as 0.000. Now, you have 2605, right? But you don't need that many. You only need where the 2 is, but the 2 has a 6 behind it. So this 2 has a 6 behind it. And since that 2 has a 6 behind it, that's going to make this 2 a 3. So your p-value, right? So your p-value you're going to report is 0.0003, okay? So be careful with that. If you see a p-value and it looks like it's over 1, make sure you look over here on the right, because p-values are probabilities. They should never be greater than 1, okay? 0.0003 is your p-value. So we go back to our whiteboard, and then we get to do the easy part, okay? So we know what our test statistic was. We copied it off our screen. So if you've already written it, then bear with me for a sec while I put it up. My test value here was negative 3.6518. Okay. And my p-value, which is the next thing, was my p-value, we just went over, that was equal to 0.0003. Now my decision is the next thing. So my step 4 here is going to be reject or do not reject the null hypothesis. So we have reject HO or do not reject HO. And so we're using the p-value approach. So we have p-value versus alpha, right? And I believe my alpha was 0.01 for that. Let me check. My alpha was 0.05 for number 4. So here, I'm going to say that my p-value was 0.05. So this is 0.5. And how does that compare to alpha? Well, it's 0.0003. Here, your p-value is larger. This is 5% and alpha is smaller. Your p-value is larger. When your p-value is larger than alpha, you do not reject.
Wait, aren't the signs wrong? Because the alpha is greater.
Alpha is over here. 0.0003. That's smaller than your p. P is actually larger in this. You're right. Alpha should, so if the p-value were smaller than alpha, okay, so if it were going the other way, we would reject the null hypothesis.
Oh, so the sign's correct then?
The sign here is correct. The p-value, which is 0.05, is larger than 0.0003. Your p-value is larger than alpha. So we do not reject the null hypothesis. Okay. And you can write under here, you can say, yeah, I don't think we've done a do not reject for a while, but this would be do not reject the null. Do not reject HO because the p-value is greater than alpha. When the p-value is greater than alpha, we do not reject the null. Now, if we do not reject the null hypothesis, then step 5, which is our summary statement, step 5 here is going to be we did not reject, so there is not enough evidence. Now, our claim was H1, so there's not enough evidence to support the claim. So we can't support the claim that the times are different in the winter. And we're going to make sure we underline is not and support. There's not enough evidence to support the claim. Okay, that's number 4. So not as much work to do, a little bit more calculator stuff, but not as much grunt work to do in going through these when you're doing it.
Okay.
Yeah? All right, that's number 4. Feel free to pause the video if you need to take a screenshot of that.
I already wrote it down.
So now let's go on to number 5. Number 5 says, the average length of, quote, short hospital stays for men is slightly longer than that for women, 5.2 days versus 4.5 days. A random sample of recent hospital stays for both men and women revealed the following, which is down below. At alpha equals 0.01, is there sufficient evidence to conclude that the average length of hospital stays for men is longer than the average stay for women? I'm going to do myself a favor and write down my data for this. Men, your sample size N is 32. X bar is 5.5. And your population standard deviation, sigma, is 1.2. Now I'm going to point out something because I noticed it in the answer key that might throw you off. Because there's a couple of ways that you could, depending on which way you made the groups. And that's why you need to tell her which group is group 1 and which group is group 2, because things happen like this. If you decide, and you certainly can, to make group 1 the men, so if group 1 here, this is group 1, and you make group 2 the women, okay? Then here it says that the average the average hospital stay for men is longer. Men is longer than the average stay for women. In that case, if group 1 is the men and group 2 is the women, then you're going to have an alternative hypothesis that's going to be right-tailed for this, okay? If you decided to make the women group 1, then it would go the other way. That's why you need to specify, because you need to make sure that whatever group the men is, whether it's group 2 or group 1, that you're saying that their mean is bigger, okay? Or that you believe their mean is bigger. So in this case, what we're going to do, go back to our lovely whiteboard again. Okay, and we go, here's number 5. So we're going to have, this is number 5. And we're going to start the way we always start, parameter. We have population mean difference, or population mean mu. Then we have, and we should make this a capital letter probably. There we go. And then we have our method and our test. So our test is going to be a 2-sample z-test with statistics. We're going to have our method going to be the p-value approach. And we're going to have the claim actually. Let me put, well, yeah, I can put my claim and then put my groups. My claim is going to be that men stay longer than women. So I'm going to say H1 is mu1 is greater than mu2. And I want to be writing in caps here. Mu1 is greater than mu2, where we let group 1 equal the men and group 2 equal the women. So here, group 2 is the women. Now, we do the whole thing. So this is going to look very familiar after a while. Step 1, your null hypothesis. So it's, now be a little bit careful because we haven't done this for a minute. HO. Here, our test is a right tail, which I should put that up here also. It's a right-tailed test. So when you write your null hypothesis, remember that you're going to need a lesser or equal to. So mu1 here, this is going to be mu1 is we're going to write less than or equal to. So we're going to say less than or equal to, which I'm going to sneak up there and sneak a line under it. That's about as good as I can get. This is going to be mu2 now. So this is going to be our mu2 over here. Okay, and then our H1 is going to be mu1 H1. Mu1 is greater than mu2. Men stay longer than women do. So we have that. Now this is a right tail test, and it's also the claim. So this is the claim here, and it's a right tail. And if you want to write your statistical equivalent for step 1, remember we were writing the two-sided arrow statement, so we were doing our equivalence with this. So this is, you don't have to make it as big as I am here. I'm just trying to make the symbol the way it's supposed to be. HO is going to be HO mu1 equals mu2, because remember we always state that the null is equal. So HO here, HO, there we go. And this is going to be HO, mu1 is equal to mu2. So this is mu1 equals mu2. Now I can go to my calculator, plug in my numbers. Let me make sure I'm screen sharing the calculator. I wasn't. Okay, stats, tests, 2 sample Z with stat, oops, nope, see I'm on the wrong one. Stats, tests, 2 sample Z, number 3 on my menu, good. Now make sure you're on stats. And for this one, the men have a standard deviation of 1.2. The women have a standard deviation of 1.5. So this is going to be 1.5. Your men have a sample mean of 5.5. And a sample size of 32. The women have a sample mean of 4.2 with a sample size of 30. Okay. Then we make sure your test is going to the right, that the group 1 men we suspect is longer. So we want to make sure that you change your alternative to me too. Make sure you hit enter if you're on greater than mu2, make sure you hit enter so that it locks it in calculated. I have Z is 3.7523. V 3.7523. And your p-value, okay, once again, we have that 8 with the -5. So this is going to be, p-value is going to be 0.1234. And the fifth one is going to be 8. So that's going to be 4 zeros and an 8, which if we want to round this to 4 decimal places, is going to be 0.0001. So your p-value is 0.0001. Let's go back to our whiteboard, put our stuff on it, and we'll put it in here. So step 2, our test statistic or our test value was test value was V equals 3.75 23. Your p-value, step 3, was 0.1234. And then your step 4 is going to be reject the null or do not reject the null. So we do this thing here. So we get reject HO or do not reject HO. And once again, we compare our p-value to our alpha, right? So your p-value is 0.123. And then here you get, I believe our alpha here was 0.01. Be a little bit careful. There's a lot of zeros floating around. Let me verify that that's what our alpha is actually. Yeah, alpha 0.01 for number 5. So here we're going to say that when you're comparing here, you get to the 1 in alpha before you get to the 1 in the p-value. So your p-value here is actually smaller than your p-value is smaller than alpha, okay? This one's actually smaller. And so that leads us to reject the null hypothesis, okay? We reject the null. And so step 5 Well, let's finish step 4 first. We reject the null, reject HO because p-value is less than alpha. And so step 5, we rejected the null. Our claim was the alternative hypothesis. So we can say that there is enough evidence to support the claim. So there is enough evidence to support the claim. And if you want to write for some context up here, you can say that your claim was H1 and your decision was reject HO. Remember, that's your flow chart if you need it. Okay, that's your step there. You ready for number 6, Tracer?
Yeah.
Yeah? Okay, so let's go on.
I have a question.
Yes.
Do you have the samples for this?
For this section? I'll
Yeah.
check. I know that she added some new ones to this, so that's why I did. I'll check and see what I have. I have the ones for 9.4 for sure.
Okay.
And I did number 10 on the video. I did number 10 already on the other video that I was showing you earlier. Because after number 8 or so, it changes to confidence interval. So 9 and 10 are confidence intervals. Did you want to try those on your own? Or did you want to go to 9.4 instead? Oh, because it's 6 after already. That's why. But I'll check it and see what I have and let you know.
All right.
Okay.
Sure.
All right. Did you got this one?
Not really.
Okay. You want me to leave it up?
Yeah.
I can do that.
Oh, I already got 5. I'm already finished with 5. I'm already on 6.
Okay. Okay, well, work on that, and then I'll send you what I have, and there'll probably be another video later, depending on how people do. I already put up one for 9.4, but if people need additional help with this section, then I'll do it. Let me check the actual work and see, because some of those problems I did because the key